All right, double and half angle identities. Brace yourself, folks. This is kind of a long one, and I apologize in advance. Okay. So we have some identities here, and we're going to get the double angle identities from these sum identities, okay? So sine of 2 theta, which is what I'm trying to get, that would be a double angle identity right there. I could just change that to be sine of theta plus theta, which really now theta, both of those thetas are a's. So if I plug that into that equation right above it, I end up getting sine of theta cosine of theta plus cosine of theta sine of theta, which really, that's the same thing. Like this and this are the same exact thing. So this is equal to 2 sine of theta cosine of theta. I just put the sine of theta first. Cool? Really cool. All right, so then cosine of 2 theta, well, that's the same as cosine of theta plus theta, which again, I could plug that into this equation up here, and I'm going to end up with cosine of theta minus sine of theta, which is cosine squared of theta minus sine squared of theta. So cosine of 2 theta is cosine squared minus sine squared. Now that looks a lot like something we've done in the past, right? That looks a lot like the Pythagorean identity. So sine squared plus cosine squared equals 1. So if I solve that for sine squared, I get 1 minus cosine squared. And if I plug that into there, I'm going to get cosine of 2 theta is cosine squared of theta minus 1 minus cosine squared of theta, which if you distribute that, you end up with 2 cosine squared of theta minus 1. So that one right there is another of the cosine double angles. Okay, there's 3 of them. There's one more, and we can do the same thing by solving for cosine squared, and you get 1 minus sine squared. So then if I go in and plug that in right there, I'm going to get 1 minus sine squared, which is equal to 1 minus 2 sine squared of theta. So there's 3 different identities for the cosine of 2 theta. Okay, so those 4 right there are the sine's double angle and the cosine double angle. Okay. All right, so let's do tangent too. So same thing with tangent. If I have tangent of a plus b, well, that's going to be tangent of 2 theta, which is really tangent of theta plus theta. And I could go plug that in, and that's tangent theta plus tangent theta, and then 1 minus tangent theta times tangent theta, which is 2 tangent of theta over 1 minus tangent squared. That is the double angle for tangent equation. Got it? All right, kind of cool. That's where they come from. And so then we are going to use these equations, okay? So if we have cosine of theta equals 8 over 17, and theta is between 3 pi halves and 2 pi, we want to find sine of 2 theta. So that 3 pi halves to 2 pi, that means that this is in the 4th quadrant. So I can just draw an angle into the 4th quadrant. Okay, and I can drop this back and I can create a triangle. And then we're going to use SOHCAHTOA. So cosine is adjacent over hypotenuse, which the adjacent side here is 8, which would be the x length, and the hypotenuse is 17 because of this right here. So this is the adjacent side, and this is the hypotenuse. Okay. So then I can find that other one just by doing Pythagorean theorem. And we end up getting b equals positive or negative 15, which in this case it's going to be negative because it went down into the x-axis, or into the lower quadrant. Okay? And then I'm finding sine of 2 theta, so that's 2 sine of theta cosine of theta. So I first need to set up the picture. And then I'm going to go find 2 sine of theta cosine of theta. Well, sine of theta is negative 15 over 17. So then I can just plug that in. So sine of 2 theta is 2 sine of theta cosine of theta. I know sine of theta is negative... I flipped those. Sorry, guys. I hope that didn't confuse your brains. This right here I accidentally put there and this there. It doesn't matter because they're commutative, but I put cosine first, so 8 over 17 times negative 15 over 17. So if you were to write it right here, it'd be 2 negative 15 over 17, 8 over 17. I think you get that, but I'm sure I confused a couple. Anyways, okay, so multiply all that together, and we get negative 240 over 289. Okay, so that means sine of 2, whoopsie, I didn't write it. Sine of 2 theta equals negative 240 over 289. Okay, cool? Way cool. All right, next. So now it says that sine is negative 1/3 and theta is between pi and 3 pi halves. So that means it's in the third quadrant. It's right there. And then I can, again, drop this back, create a triangle. Sine, what does that say? Can you teach me about SOHCAHTOA? No. Okay, anyway, so sine is opposite over hypotenuse. So that's negative 3 over 3. Or negative 1 over 3, my bad. Okay, we can find that other side by doing Pythagorean theorem, blah, blah, blah. We get 2 squared roots of 2. So then that is going to be our length going back. So that negative 2 square roots of 2. Cool? So then tangent of 2 theta is what I'm trying to find. And so I need to figure out what tangent is. Well, tangent is opposite over adjacent. So that's negative 1 over negative 2 square roots of 2. Which becomes becomes 1 over 2 square roots of 2. Multiply by 2 square roots of 2. And you get the square root of 2 over 4. Always rationalize first. Do this first. Sorry, my handwriting is really bad right now because I forgot my pencil at home. Anyways. So we have to do that first. I'm writing with my finger. Okay, so then I'm going to plug that into the equation. So tangent of 2 theta is 2 tangent of theta minus tangent squared. So that's 2 times the square root of 2 over 4. And then over 1 minus square root of 2 over 4. You multiply that out and you get square root of 2 over 2 over 1 minus 2 over 16. Okay, I'm just simplifying these square roots. So like this right here, this 2 cancels that. I'm left with 2 on the bottom. If I square the top there, I'm just left with 2. Square the bottom, I'm left with 16. Okay. And then I want to get that 2 over 16 reduces to 1 over 8. Then that 1 over 8. And I just don't want to lose anyone. So this would be 8 over 8. I can change that to be 8 over 8. And then 8 minus 1 is 7. So that's where I get that. And then the 8 stays. Okay. And then I'm going to divide that, flip and multiply. 2 goes in 8 4 times. So I'm left with 4 square roots of 2 over 7. Okay, a lot of this is just simplifying square roots. And so it's a lot of work with square roots to make sure you get good with those. Okay, so tangent of 2 theta is 4 square roots of 2 over 7. Cool? Okay, let's get the half angle identities. So we're going to use the cosine of 2 theta. We're going to use these 2 equations to get the half angle ones. So I could just say that theta equals 1/2 of theta, which is the same as theta over 2. So if I plug that into equation 1, I get 2 times theta over 2, 1 minus 2 sine squared of theta over 2. Well, that just becomes cosine of theta, and then 1 minus 2 sine squared of theta over 2. Because here, these 2's just cancel out, right? Cancel. Okay, so then I'm going to be left with, I just subtract that 1 over. So negative 1 plus cosine of theta equals negative 2 sine squared of theta over 2. Multiply everything by negative to get rid of that. So all of the signs are going to flip. And then I'm going to divide by 2. So I divide both sides here by 2. So this divides by 2. This divides by 2. And I'm left with 1 minus cosine of theta over 2 equals sine squared of theta over 2. Square root both sides, and we end up with our equation. That's the half angle equation. Kind of cool. All right, let's do equation 2. No way, Jose. Okay, kind of the same thing. Those 2's are going to cancel. I'm left with cosine of theta and 2 cosine squared of theta over 2 minus 1. Add that 1 over, divide by 2. Square root both sides, and bam, we end up with that equation. Now, you don't need to really, like, remember how to get here. It's just kind of cool to at least see it. Like, no one ever showed me this in school, and I always just thought, like, poof, this equation came out of thin air, and it didn't, okay? So cool. All right, tangent. So, Titanic. Okay, anyways. So, tangent is sine over cosine. So, that means if I put just theta to be theta over 2, tangent of theta over 2 is sine of theta over 2 over cosine of theta over 2. So, we have these square root equations. I can plug those in there. But, like, how in the world am I going to simplify that? That looks so scary. Okay, so let's just do one with numbers. So, I have the square root of 3 over 2 over the square root of 2 over 3. Well, when we multiply square roots, when we just do like square root of 2 times square root of 3, that equals the square root of 6, right? Which really, if we were to divide, so if I do square root of 2 over square root of 3, we could just combine that to be square root of 2 over 3. So I could just combine this over here to be one thing under the square root. So then this is going to be square root of 3 over 2 over 2 over 3. Which that's division, so I can write it as division so it doesn't look so crazy. Flip and multiply, and I'm left with the square root of 9 over 4, which is really 3/2. And if you were to put that in a calculator, you'll get 1.5 out. Kind of cool. So it works, so that means I can do it over here. Okay, so I can put these under the square root, and I can flip and divide them, flip and multiply, and those 2's cancel, so I'm left with 1 minus cosine of theta over cosine of theta plus 1. And I'm just going to rewrite that as 1 plus cosine of theta. Okay? And that is what tangent of theta over 2 equals. Kind of cool. Okay, so then there's a couple other tangent equations, and I'll try and go through this kind of fast. So I could multiply by the reciprocal of the bottom, so 1 minus cosine of theta. And if we multiply that out, I end up with 1 minus cosine of theta squared on top over 1 minus cosine squared of theta. These two down here, if we multiply them, like I could use the box real quick. So 1 cosine of theta, 1 negative cos of theta. So this is 1, this is cosine, this is negative cosine, this is negative cosine squared. So then those cancel and you're just left with this. These ones were the same exact thing. So they just become squared. Okay. So then 1 minus cosine squared of theta, well, that's Pythagorean. So that's the same as sine squared of theta. Square root that, and I'm left with 1 minus cosine over sine of theta. Kind of cool. Let's do this one. Oh, so that's the second one. There's one more. So now if I multiply by 1 plus cosine of theta, so now the reciprocal of the top becomes 1 minus cosine squared, and the bottom becomes 1 plus cosine squared. Because this multiplication right here was the same as this multiplication right here. So that's why these end up being the same thing. Okay, so then I can square root that, and 1 minus cosine squared is the same as sine, so you end up with sine over 1 plus cosine. So there's our 3 equations. Okay, all right, so we're going to use these to find half angles. So if I want to find the exact value of 67.5, well, if I multiply 67.5 by 2, okay, first, sorry, back up. 67.5 is right there. It's in the first quadrant. And cosine is positive in the first quadrant. That is important to us. Okay, we need to figure out whether it's positive or negative, because depending what quadrant it is in over here, it could be negative. Because if it was in the second quadrant, cosine would be negative. Third quadrant, cosine would be negative. And same with, and the fourth quadrant, it'd be positive. Okay, so then if I multiply 67.5 by 2, I get 135. So I have cosine of 67.5 is the same as cosine of 135 over 2, which means that 135 is acting as my theta. So I can plug that in to this equation right here, where theta equals 1 over 135. Okay, so then here, cosine of 135, unit circle, pull it out, find the cosine of 135. You're going to get negative square root of 2 over 2. Then it's just back to simplifying. So then that's going to become a minus. I can put that be 2 over 2. If I subtract that, I have 2 minus the square root of 2 over 2, and that's all over 2, So I can divide that. So 2, I just put that over 1. Flip and multiply, and I get square root of 2 minus the square root of 2 over 4. Square root, top and bottom, and I'm left with 2 minus the square root of 2 over 2. Okay, so cosine of 67.5 is is the square root of 2 minus the square root of 2 over 2. Lots of 2's. Okay, let's do another. Okay, this one. So sine of 11 pi halves. Well, 11 pi halves is the same as 165, which is in the second quadrant, and sine is positive there. So then I can multiply that by 2, and I get 330 over 2, which I know this is positive, so I'm just going to look at the positive, and it's 1 minus cosine of 330 over 2. Again, look at your unit circle. Cosine of 330 is the square root of 3 over 2. Start to simplify this, and we end up with 2 minus the square root of 3 over 2, all over 2. Divide, flip and multiply, and I get the square root of 2 minus the square root of 3 over 4, which is the square root of 2 minus the square root of 3 over 2. Wowza, that was a lot, okay? Oh, yep, that's a lot. See, that's why I put these like little memes in there, because that's how I'm feeling in that moment, like, holy cow. Okay, so anyways, next. This one, so if sine is negative 12 over 13, and it is in the fourth quadrant, yeah, I know, 3 pi halves to 2 pi, and we want to find tangent of theta over 2. So this is a little bit different type of problem. So they're giving us a ratio for sine. Instead of giving us an angle, we're given a ratio. So that means I'm going to draw a triangle here, okay? So there's my triangle, and sine is opposite over hypotenuse, so that's negative 12 over 13. Okay, we've been drawing triangles with this, so hopefully you guys understand that part. Now, I need to figure out, I'm trying to find the tangent of theta over 2, not tangent of theta. So I'm going to move this over here. And I'm going to divide all of those numbers there by 2, because that's going to give me theta over 2. So if I do 3 pi halves divided by 2, well, I can flip and multiply that, and that's 3 pi fourths. So theta halves is between 3 pi fourths and pi, which that is in the second quadrant. So that means that the half angle is in the second quadrant. Okay, which kind of makes sense, because like this would be like half of the rotation. This is the other half of the rotation to get to there. Okay. So now tangent of theta is negative in the second quadrant. So that means tangent is going to be negative when we go through this. So I can find that missing side there by doing Pythagorean theorem. It's 5. And then this is going to be cosine is 5/13. And I'm going to use one of these two equations instead of my square root equation. Okay, I would just not even use the square root equation, quite frankly. But then this is going to be tangent. I'm going to use that first equation. So that's going to be 1 minus 5/13 over negative 12 over 13. Which 13/13 minus 5/13 over 12/13 is 8 over 13 over negative 12 over 13. 13s cancel. I have 8 over negative 12, which is negative 2/3. Boom. Okay. I think this is the last one. So tangent of 4 square root of 3. And it's in the third quadrant. Okay. So right there. And there's my triangle. Now, 4 square root of 3 is the same thing as negative 4 square root of 3 over negative 1. In order for that to be in the third quadrant, those could only be the possible other sides. Okay, because remember, this is a ratio, so I have to put this over 1. But since it's here, I went back and I went down, so they both have to be negative. Okay, so then I can figure out what the half angle is, divide that by 2, and I end up with pi over 2 and 3 pi over 4. So that means this is in the second quadrant, and it's a little bit closer to the y-axis. Okay, so then cosine is negative in the second quadrant. So if I am finding that, I need to find my hypotenuse here, which is 7. So cosine of theta is negative 1 over 7. Plug that into that equation, and I'm going to use the negative because I figured out that cosine is negative there. And I have 1 plus negative 1/7 over 2, which is 1 minus 1/7 over 2. 7 over 7 minus 1 over 7 over 2, which is 6 over 7 over 2. Divide that, flip and multiply, and I end up with 3/7 square root top and bottom, and rationalize. So multiply by square root of 7, and I get 3 times 7 is 21. Square root of 7 times 7 is 7. So cosine of theta over 2 is negative 20, square root of 21 over 7. Boom. Huzzah. Okay, we're done. All right. Bye, guys. Thanks for hanging in. You're awesome. See you later.